In this video series, we will learn about what an atom is, and what atoms are made of, the discovery of subatomic particles, and how the idea of non-divisible particles changed over time. We will also explore the important contribution of different physicists in this incredible journey. So let's start it. Everything around us is made of tiny particles, known as atoms. The existence of atoms has been proposed since the time of early Indian and Greek philosophers. According to them, if we take a piece of matter and keep subdividing it into smaller pieces, ultimately, a point comes where we can no longer able to subdivide that matter into further smaller pieces. This final non-divisible stage of matter is known as atom. In fact, the word atom has been derived from a Greek word atomos, which means uncuttable or non-divisible. Atoms are extremely small particles. Everything around us is composed of the repeated arrangement of atoms. But there are so many questions that puzzled scientists for a very long period of time. Like how an atom looks like, how atoms of different substances are differ from each other, and whether an atom is truly indivisible or not. The first description of an atom was given in 400 BC by the Greek philosopher Democritus. According to him, atoms are small, hard, incompressible particles. They are made up of a single material and could exist in different shapes and sizes. Democritus believed that the different physical and chemical properties of matter are due to the different shapes and sizes of atoms. He theorizes that atoms are in constant motion and, upon collision, they stick to each other. In 1808, the fundamental idea of Democritus was enhanced by the English chemist and physicist John Dalton. Dalton gave the first atomic theory. His model of an atom is often referred as a billiard ball model, because, similar to Democritus, Dalton also held the belief that atoms are extremely small, hard, indivisible particles, like a billiard ball. Dalton defined his theory with a number of postulates that explained the physical and chemical behavior of an atom. Dalton stated that all atoms of a particular element are similar in all respects, whether it be their physical or chemical properties. Later, this was proven to be wrong because of the existence of isotopes. Isotopes are atoms of the same element but with different masses due to the unequal number of neutrons. However, the concept of electrons and nucleus were unknown at that time. Dalton also stated that atoms of different elements are different in all physical and chemical properties. Later, this was also proven wrong because of the existence of isobars. Isobars are atoms of different chemical elements that have the same number of nucleons. According to Dalton, atoms combine in whole number ratios to form stable compounds. Dalton's atomic theory, despite its limitations, remains a great achievement, and we must appreciate Dalton's work. Until now, the atom was assumed to be the smallest indivisible particle, because the concept of subatomic particles, electron, proton, and neutron was unknown till that time. In 1854, Heinrich Geissler, a skilled glassblower and technical assistant to German physicist Julius Plucker, is working on the vacuum tubes. Later in 1858, Julius Plucker enclosed two electrodes within a vacuum tube and applied a high voltage, causing electric current to flow between them. This experiment revealed a mysterious green glow on the inner surface of the glass tube. At first, everyone thought that this glow is some sort of property of electric current passing between the electrodes. But in 1869, Julius Plucker and Wilhelm Hittorf conducted the same experiment with improved vacuum tubes. Conducting experiments with various gases inside the tube and different electrode materials, they observed that the glow produced in the vacuum tube is independent of both nature of gas and the electrode material. When an object is placed in front of the cathode, it casts a shadow in the glow, which proves that the glow is produced by some sort of rays coming from the cathode. Later, these rays came to be known as cathode rays. But the nature of cathode rays is very controversial. Most French and British physicists believe they are electrically charged particles. On the other hand, most German physicists thought of cathode rays as some sort of waves. In 1879, an English physicist and chemist, William Crookes, investigated cathode rays and found that they were bent by a magnetic field. The direction of deflection suggests that cathode rays consist of negatively charged particles. If we use a Crookes railway tube and apply high voltage to its electrodes, the charged particles from the cathode collide with the paddle wheel, causing movement. This demonstrates that cathode rays carry momentum and hence confirms the particle nature of cathode rays. In 1897, the English physicist J.J. Thomson worked on cathode rays, exploring the effect of electric and magnetic field on them. In his experiment, he deflected the cathode rays, which is a beam of charged particles, using electric and magnetic field. Through his experiment, he not only confirmed the particle nature of cathode rays, but also calculated the ratio of charge to the mass of these particles, by considering the amount of deflection with respect to the intensity of electric and magnetic field. J.J. Thomson named these particles corpuscles. The particles J.J. Thomson named corpuscles were later identified and named electrons. And that's how the first subatomic particle, the electron, was discovered by J.J. Thomson. After the discovery of electron, the 2,000-year-old misconception that the atom is an indivisible particle is no longer true. The discovery revealed that atom is not indivisible. Instead, it consists of subatomic particle called electron. But the question is, how electrons are arranged in an atom? In 1904, J.J. Thomson presented the first atomic model which involves the subatomic particles. This model of an atom is famous as the plum pudding model. Plum pudding model suggests that electrons are distributed uniformly within the positively charged sphere of the atom, similar to plums scattered in the pudding. We will cover the rest of this concept in the next part of this video series. Thank you so much for watching. I hope you find